Functional group parte siya ng organic molecule where most of the chemical reactions occur. So siya mismo yung responsible sa chemical reactivity ng organic molecule. And at your end, ang inyo yung i-practice diri on functional groups nga concept is the recognition of the type, the category ng functional group, so that you could relate it also sa naming format. Kasi iba-iba yung naming format, depende kung ano yung functional group present, diba, in a organic molecule. So you have to practice recognizing groups. So ang kumbaga advice sa inyo is starting today, or I believe na ana mo yung ana nga practice katong sa inyohang first year pa mo, nagsulat siguro mo in an index card, gipilit ninyo sa inyong dingding sa inyong kwarto kani mga functional group para madali yung pag-memorize. Kana isa na siya sa technique to easily familiarize slowly yung mga formula ng functional group. Kasi tedious talaga siya i-memorize basta na yung mga structure. Dili lang siya pang overnight nga pag-memorize. Kung gusto gid tag long-term nga retention, balik-balikon gid nato siya og lantaw ang structure. So try to do that sa inyong small index card. Isulat ninyo tanan, pwede kani mismo nga table. Then ipilit ninyo siya sa inyong dingding para every day uli mo before mo matulog inyo siyang lantawon para ma-familiarize ninyo. Photographic memory na lang dayon ang kumbaga mo activate during assessments. Okay, so it's already your part na good ang kanang memorization during your independent time study na good ang pag-memorize ani. Take note kapag carboxylic acid, ito yung type formula niya. It's RCOOH. You can simplify that. RCOOH. And by the way, yung kumbaga arrangement ng mga functional groups dito in this table, they are arranged from the highest priority group. Highest priority group until down to the lowest priority group. So yan yung arrangement nila dito sa table. So kumbaga, kapag nakita mo ang isang molecule, meron siyang carboxylic acid, then we are sure enough nga kung papangalanan natin yung organic molecule na yan, it should end with an oic acid kasi yan yung higher priority group present in that molecule. Or halimbawa, kapag sa isang compound, meron tayong nakitang aldehyde portion sa dulo, tapos may kasama siyang ketone portion. How will you name that organic molecule since aldehyde is a higher priority group than ketone? So ire-reflect natin sa pangalan niya, it should end with an al. Or kung cyclic man yan, it should end with a carbaldehyde. Okay, so I hope you understand the arrangement nila dito based on higher priority from the highest priority group down to the lowest priority group. So i-memorize nyo to yung type formula, i-recall nyo lang. And then the rest, itong apat na kasunod after carboxylic acid, again yung apat, yung anhydride, ester, acyl halide, at saka yung amide, these are actually considered as derivatives of carboxylic acids. Derivatives of carboxylic acid. Pag sinabing derivatives, derived sila sa carboxylic acid. Nabubuo sila out of chemical reactions na nangyari sa carboxylic acid. So meaning to say, kung i-relate nyo naman sa naming format, in order for you to easily name an anhydride, an ester, an acyl halide, or an amide, you should learn first how to name carboxylic acid. Kaya galing daw din naman sila sa carboxylic acid. So kung master nyo yung naming ng carboxylic acid, then everything follows na kung mag-derive siya og ester, mag-derive siya og amide. Mag-change lang ka, nalay changes sa iyahang, sort of sa iyahang suffixes. Ayan. So for anhydride, kung titingnan natin, meron siyang dalawang carboxylic acid group. So kumbaga nabubuo yung anhydride by reaction of 2 carboxylic acid. Ire-react mo lang yung dalawang carboxylic acid, mabubuo yung acid anhydride. And sa iyahang type formula na nakalabel nga R1, and this is another organic chain. So gilabel lang siya as R2. This is just to identify, no, that meron tayong organic chain na bumubuo sa unang carboxylic acid part niya. Meron ding organic chain na bumubuo sa second carboxylic acid portion ng anhydride. Okay? And in naming, paano ba yung name format niya? Alkanoic anhydride naman. So, kumbaga, yung R portion, organic portion, they are not the same man. So, you have to name them, state them separately. So, halimbawa, kung this is, halimbawa, yung R1 is a CH3. Any alkyl group, any organic carbon chain, yan yung ibig sabihin ng R, di ba? Any organic molecule, any carbon chain. So, halimbawa, it's methyl dyan. So, dalawang carbon yan. Let me change the color para mas na ay clarity. Carbon 1 and carbon 2. So, 2 carbon, that's ethanoic. No? 2 carbons, di ba, is F. So, that portion is ethanoic. And let's say dito, yung portion na to is just a hydrogen. Halimbawa lang, hydrogen. So, it has only 1 carbon. So, that's methanoic. Okay, so when you name them, the R portion, name them separately. Yan lang yung ibig sabihin. Then, alphabetization man na, di ba? Ethanoic, ang isa. Ito, halimbawa lang, ethanoic. Then, itong portion na to is methanoic. Then, dagdagan nyo ng anhydride. Kasi, the organic molecule, functional group present is anhydride. So, ethanoic, methanoic, anhydride. Okay? Ester, acyl halide, and amide are also derivatives of carboxylic acid. So, in naming, i-recall natin yung sa ester. They usually end with a suffix O8. Okay, so yan yung kumbaga name format niya. Yung suffix is O8. And meron din siyang different carbon chain present based sa iyang type formula. Kaning R1 nga ginalabel, that's part of the root name. That's part of the parent name. Okay, kasi magsisimula, di ba, yung counting sa alpha carbon. Alpha carbon is actually the carbon holding the functional group. Yan palagi yung alpha carbon. Okay, it holds, di ba, the ester portion. So, siya yung alpha carbon. The carbon ulit holding the functional group, it's the alpha carbon. So, yan, carbon 1. Then, halimbawa, yung first carbon chain or, first carbon chain dyan is, let's say, methyl ulit. Okay? Methyl. So, ito yung pangalawang carbon. So, yung alkyl group, the number of carbon in the parent chain, dalawa. Dalawa yung carbon in the parent portion ng ester. So, that's ethanoate. Tama? Ethanoate. Ito yung sa parent chain. So, yung R1 nga portion daw, part siya sa parent name. Okay, so nag-specify man ta nga methyl tong R1. So, may mo na siya ethanoate. S means 2 carbon. Okay? And then yung R2 dyan, that could be any alkyl part. Pwede na siya methyl, ethyl, isopropyl, whatever. Basta, alkyl part na siya. So, in naming, sabi sa naming format, unahon nimo ang R2. Unahon daw nimo ang alkyl part pag state, followed by the parent name. Okay? This is daw the alkyl part. So, let's say, atong hatagan, o alkyl part. Halimbawa, this is CH3. So, mahimo siya methyl ethanoate. Diba? That's how we name it kapag ester. Okay? Then you do the same, no, sa the rest of the functional group. Basta ka nang kanang first portion are the prefixes. That is being determined by simply counting the number of carbon sa parent chain. Yun naman talaga, di ba, ang root parent name. Dapat kabaluta, pila ang longest carbon chain in that organic molecule. Then i-reflect na to using Greek prefixes that describes or dictates number. Kung isa, meth. Kung duha, eth. Tolo, prop. Apat ang carbon chain, but. Then 5, pent, etc. Then, ito naman acyl halide. Ito yung acyl portion. Then you have a halogen. Pwede na mo siya i-simplify. RC, then OX. Carbon is double bond to O. The halogen is attached to the carbonyl carbon. Okay? Amide. Amide naman, you have also a carbonyl portion na kung saan on the carbonyl carbon may direct attachment ng nitrogen, single bonded to nitrogen. Okay? So that's an amide. Halimbawa, itong organic portion na to, palitan natin halimbawa ng CH3, then CH2. So pila naman naka-carbon? 1, 2, 3. So kung 3 ang root name ng kanyang parent, indicating the number of carbon is prop. Tama? Tumay mo siya, prop panamide. Okay? Sorry, padali lang ha. Ito i-delete na. Okay. Prop panamide. Okay? Propane, then amide. Okay. Diba? From propane, then amide yun. Okay. Ano siya, mag-name og organic molecule. So mainly, naagi relationship no ang naming format to the type formula. Magbase gid siya. Naa siya template kung ano yung suffix, kung carboxylic acid, ano yung suffix kapag ester, ano yung suffix kapag amide. Okay? So it starts with familiarization with the type formula. You should know how to identify nitrile ba na, alkane ba na, alkene ba na, so that you will know ano yung magiging suffix ending niya. Kung nakita nimo carboxylic ang naa sa iya ha, then we're sure enough nga siyang pangalan, it should end with oic acid. Okay? Usually sa mga board exam question, wala man kayo masyado nga ipa-name mo. Kanilang gid siya nga portion is this will be your foundation in learning biochemistry. Kasi biochemistry dagan kaayo structure samot no sa biochemistry. So how will you understand no more complex nga chemistry topic if classifying organic molecule pa lang hindi kayo familiar. So kumbaga itong knowledge nyo is foundation sa inyong biochem. Okay? So dili kayo siya gina-question sa board exam nga ipa-name mo. Although base na anay isa pero it's the basic good nga question ang masama. Okay? Sige. Ito, familiar naman kayo nito sa nitrile, carbon triple bond to nitrogen. Kapag aldehyde, it's RCHO. Kapag ketone, RCOR. Diba? Pag alcohol, kani, I believe, wala man good siguro yung marong, no? Kung ipa-identify mo unsang functional group ng alcohol, it's the OH, the ROH. Okay? Thiol naman, we simply change the oxygen from alcohol into sulfur. Basta may thio. Thio indicates sulfur atom. Again, thio indicates sulfur atom. Amine naman kapag carbon single bond to nitrogen. Kaya may nakalagay dyan. An R group, usually represented gina siya with a carbon. Ang R group. Okay? Carbon chain na siya usually. Okay? Single bond to nitrogen, amine yan. Then ito, alkyne, carbon to carbon triple bond, double bond to carbon is alkene. Kapag single bond, carbon to carbon, that's alkene. Okay, then yung sineparate dito sa table, These are classified as low priority substituents. Pag sinabing low priority substituents, usually, they act as branch points only. Branches lang siya ba? Substituents lang sila, which are being prefixed. They are not part of the parent. Okay? Dili siya appeal sa counting sa carbon in the parent chain. Substituent lang sila. Kaya low priority sila ng mga grupo. Pag sinabing higher priority, talagang part sila sa parent chain. Yun yung highest priority group. So example of lowest priority group, very common, di ba? Ang mga alkyl groups, kana man gid atong una gina-identify in naming organic molecule. We identify first in in stating na the name. In stating na the name, atog yung i-reflect una ang alkyl names. They will serve as prefixes. Okay, again, this serves as prefixes, kumbaga, ng organic compound name. Okay. Ayan. So, halimbawa, sa given na type formula, yung portion na yan, nga in bold font, yung ganito ba? That's the alkyl group. So, magbigay tayo ng halimbawa. Let's say, sige, 5 carbon chain in the parent, tapos may sanga. Okay? So, this portion is the alkyl portion in a methyl. Methyl nga, kumbaga, structure ni siya, methyl nga substituent. Then, attach siya sa carbon 2 ng parent pentane. Ayan. So, this is named as 2-methyl pentane. Okay, so yan yung halimbawa ng presence of an alkyl attached to the main chain, attached to the parent chain. Another nga low priority group is the OR, yung alkoxy, nga derived from ether. Diba? Usually, yung common way to name ether is using this identifier nga. I-identify sa nato una ang alkoxy portion, yung OR portion. It's actually an alkyl na merong oxygen. Diba? Ang alkyl is only an R group attached to the parent chain, okay, ng organic molecule. Kung ang R group naka-attach siya sa parent chain with an oxygen, then that's already alkoxy. Halimbawa, sige, pentane ulit yung parent. Okay, again, pentane ulit yung parent chain, tapos may nakita tayong, instead of methyl, ano na siya, OCH3. Ayan, OCH3. So, mahimo na siya. Hindi na yan methyl. Methoxy na yan. Methoxy. Kasi sabi natin, alkoxy is the name format. So, meron siya methoxy. So, that's 2-methoxy pentane. So, this is a lower priority group kasi it's only a substituent, not part of the parent name. Are you following? Can you show a thumbs up, please? Kung na-follow ra. Okay. Sige. Now, for thioether naman, a low priority substituent na pwede nating ma-derive sa kanya is yung alkyl thio. It looks like alkoxy. Simply change the oxygen with sulfur. So, mahimo na siya alkyl thio na. Again, simply change the oxygen to sulfur. So, mahimo na siya alkyl, then thio. So, example. Sige. I-pattern lang yapon nato sa given example above. Pentane pa rin yung parent. Okay, pentane. And then, yung sanga sa carbon 2 is S then CH3. So, mahimo ni siya methyl thio. Methyl thio. Okay, alkyl thio man daw ang name format kapag SR yung branch or substituent. So, mayroon siya 2-methyl thio. Then, pentane as the parent. And then finally, Pinaka-common din yung halogen. Di ba? Ang halogen, naapod ni sila makita as substituent sa mga organic molecule. And we also identify this as prefix. It is being prefixed sa name ng organic compound. Okay? Yes, you're raising your hand, Miss Medina. So yung X and then branch point, yan naman is halo. So, imo lang kumbaga identify with the halogen. May it be a chloro, ends with an O. So, may siya chloro, fluoro, bromo, iodo. Okay, example. Sige, parent name pa rin is pentane. Dion, there is a carbon 2, is already a chloro. So, may siya 2-chloro, pentane. Okay? So, that's it. So, familiarize this ha, yung mga functional groups in that name format. Okay. It is also important that we familiarize certain terms encountered in organic chemistry. Kindly take note, in a structure, pwedeng open chain, Ayan. Pwedeng open chain yung organic structure. Pag sinabing open chain, there is no cyclic ring present. It does not close to form a ring. It could either be a straight chain lang, so linear, or may mga branches, may mga sanga-sanga. It could be 3 or more branch points, 3 or more terminal points. Kung linear straight chain lang, syempre, dulo to dulo lang, dalawang yung terminal points. Pero kung maraming branches, marami din siyang terminal points. Kaya may nakalagay dyan, 3 or more terminal points. Halimbawa, ito, pentane. Straight chain lang. So, ang iyahang terminal points, dalawa lang. Okay? 2 terminal points. Pero kung lagyan natin siya ng sanga, o maraming sanga, so marami na din siyang terminal points. Pwedeng dito, dito. Okay? Those are terminal points. Yung dulo. Yung kumbaga free. Walang naka-attach na sa kanya. Kapag sinabing cyclic naman, it closes to form a ring. So I know you're familiar with this. Kapag yung carbon to carbon to carbon connection or carbon to other electronegative atoms connection, they close into a ring form. That's cyclic. Saturated, kapag sa isang organic structure, puro single bonds yung makikita. Okay? Kung puro single bonds yan, halimbawa, alkanes. Diba? Kapag alkanes, carbon to carbon, single bond ring yun itong ma-observe. So, that's an example of saturated. Okay? Unsaturated naman, kapag may double bond ba or triple bond, kapag may multiple bonds. Halimbawa, si carbon to carbon double bond, si carbon to carbon triple bond. So, multiple bonds na yung present. Unsaturated yun. Pag sinabing internal nga term, it is found inside an open chain. So, halimbawa, ito. This is an internal group. Ito din, internal group. Sa isang open chain, makikita siya inside, hindi sa terminal portion. So, that's internal. In a ring, halimbawa, you have a cyclohexane. Whatever substituents na makikita natin sa isang ring, that is always considered internal. Kasi wala namang dulo, di ba, kapag cycle. It doesn't end kapag cycle. So, lahat ng substituents, internal. Terminal, they have found at the end of the open chain. So, ito yun. Ito yung change in color, ha? The terminal. Terminal. Okay? End of an open chain. Alpha carbon, nasabi natin yun kanina, it is the carbon directly attached or holding the functional group. Sa biochemistry, you will be encountering also the term alpha carbon. Basta isipin nyo, alpha carbon is the carbon that is the one that holds the higher priority group or the functional group in that molecule. Pag sinabi namang primary, isa lang yung R group attached to an alpha carbon. So, halimbawa, this is a carbon, the alpha carbon. Tapos, isa lang yung R group attached to it. Okay? Then the rest, halimbawa, are hydrogens. So, that's primary. Then, pag secondary, kapag dalawa na yung R group attached to alpha carbon tertiary, kapag tatlo na yung R group. So, somehow, madali lang siyang intindihin na. So, you try to draw also its secondary, its tertiary, and quaternary. Okay? Quaternary kapag apat. Itong apat na to, puro na siya R groups. Puro na siya carbon. Puro na siya carbon surrounding the alpha carbon. Yun yung quaternary. Kapag olefinic vinylic, this is the carbon holding a double bond. Example, sa isang structure nga, let's say, sorry kayo, ayan. Sige, CH3, CH, so may double bond. Ayan, then CH3. Ito mismong carbon na to, which is in sp2. sp2, hybridized nga carbon. Sige, later, we'll review on that, the hybridization. Kapag naka-sp2 hybridized, automatic, meron yun na siyang isang double bond ang isang carbon. sp2 hybridized, yan yung palatandaan natin. Easier way to identify if the carbon is in sp2 hybridized. Kapag may one double bond only nga iyahang ginahold. Okay? So these carbons, yung two carbons sharing a double bond, again, yung dalawang to, sharing a double bond, holding a double bond, tawag sa kanila are vinyl carbons. Or, yun na nga, ano yung sabi dyan sa slide, vinylic or olefinic. Parehas na siya. Kasi makadungo mong vinyl carbon, olefinic carbon, vinylic carbon. It's the carbon holding a double bond. Yung adjacent naman sa kanya, to change ang color, kanya siya. Yung kasunod mismo na carbon, kanya silang duha, yung adjacent na carbon next to a vinyl carbon, we call them allylic or allyl carbon. Okay, allylic or allyl carbon. Again, the carbon adjacent mismo, yung katabi mismo ng carbon na may double bond. Allyl carbon yun. Acyl group naman, it's an alkyl. So, alkyl, di ba, is, ganito yung alkyl. An R group. With an additional carbonyl. So, kumbaga, naka-attach siya sa isang carbonyl. Carbon. Yan mismo yung acyl. Okay? Meron kang alkyl nga attach sa isang carbonyl. Carbonyl is, ito. That is the carbonyl. Yung kag-acyl, yung buong, ayan. Yung ito, yung buo. Yan yung acyl. Yung buo, ayan. Are you following? Can you show a thumbs up if klaro sa inyong end? Sige. Okay, let's have this topic naman on organic naming or representing an organic molecule based on its structural formula. So you're familiar with this, diba? Yung calculate, condensed, then skeletal. Pag sinabing calculate or expanded na structural formula, sabi dito sa definition, lahat ng letters or bonds, they are drawn. Again, lahat ng letters and bonds, bonding line, drawn. Including the carbon-to-carbon single bond. So, halimbawa, carbon to carbon, example, the formula or kung the compound is ethane. Pag ethane, di ba, F means 2. 2 carbon. And it's an alkane compound. So, 2 carbon, then you complete the structure by supplying the remaining hydrogen. This is an example of a calculate or expanded na structural formula of ethane. Gidraw na to ang mga lahat ng bonding lines na nagkokonekta, each atoms, and lahat ng letra. It's visible. Okay? Kapag condensed naman, condensed equivalent of ethane, yung mga single bonds are now hidden. Okay? Single bonds are now hidden. But, pag meron naman siyang present na double or triple bonds, they are often shown. So, kung ethane ato ang basihan, ato siyang i-condense, so mahimo siya CH3, CH3. Again, lahat ng single bonds are hidden. That's condensed. Okay? Kapag sinabing skeletal naman, all carbons are drawn as points. So, atong i-draw ang yung sa ethane kasi dalawa lang yung carbon, so you will just write it like that. So, kaning dalawang points that represents 2 carbons. So, habain natin. Try natin, halimbawa, yung skeletal na may functional groups na alcohol or thiol or amine. Okay? Kindly take note ha, basahin natin. All single, double, or triple bonds, they are drawn kapag skeletal. Siyempre, kasi skeletal man siya, dapat lahat ng bonding lines na bumubuo sa parent chain, it should be drawn. Except kapag yung functional group contains an OH. So, kumbaga, kapag alcohol, you don't have to write it this way. Kung alcohol ang iyahang functional group written in skeletal formula, it's okay nga diretso naka OH. Mura na siyang pasabot sa statement. Halimbawa, kung may kung thiol yung given, dili necessary nga imo pud siyang i-emphasize yung bond between sulfur and hydrogen. It's okay nga SH na agad. Okay? So in a skeletal structure pala, or skeletal formula, what is being kumbaga hidden sa parent chain, okay, what is being kumbaga considered imaginary na naka-attach nga atom sa each carbon in the parent chain kapag skeletal, it's the hydrogen. Okay, hydrogen, imaginary sila. Yung mismong hydrogen lang ha, nga attach sa carbon ng parent chain. Yung hydrogen nga attach sa carbon no, ng parent chain. Imaginary sila. And then yung mga points dyan, yung mga corners in a skeletal structure, carbon yun lahat. Carbon. Okay, next. Still under organic nomenclature, it's also important that we are aware nga meron tayong different type of names. Natay systematic name. Pag sinabing systematic name, this is following the set of rules na provided by the IUPAC. Okay? This is set by IUPAC, yung International Union of Pure Applied Chemistry. Diba? Sila yung nagsiset ng mga rules in naming different compounds, mapa inorganic or organic. That's IUPAC. Okay, so systematic, following the system. Naputay trivial name. Yun yung nickname. Yun yung traditional, yung familiar sa general community. Okay, familiarization, based sa familiarization ng people. Yung lagi siya, kumbaga para siyang common name. Ginagamit siya instead of its systematic name. So merong mga ganun. Then kapag sinabing semi-systemic, meron siyang portion na systematic, meron din siyang part nga trivial. So, ano siya, combo ng systematic, and then meron siyang trivial portion. Sige, halimbawa, let's say, yung ethanoic acid. Obviously, kung mayroon ethanoic acid, agad-agad we could tell nga, okay, it's following talaga the systematic name. Base sa table na sinabi natin kanina, na yung IUPAC name format of an acid, carboxylic acid, it should end with an oic acid. And then, yung alkane name, which is part of the parent name, is also indicated. Asa na yun. So, pag sinabing ethanoic acid, it follows the IUPAC name format nga alkanoic acid. So, no problem. Okay? IUPAC name yun. So, systematic name yan. Pero, please know also nga meron tayong mas familiar na ginagamit, no, or nickname ng ethanoic acid. Ito di ba yung vinegar? Okay? Ito din yung vinegar. Mas familiar tayo, no, sa vinegar nga term. That's actually systematically known as ethanoic acid. Pag sinabing semi-systemic, it sounds like systematic, tapos meron pa siyang kumbaga, ginagamit siya traditionally nga name din. So, kumbaga, combo ng dalawa, that's systematic name. Yung acetic acid. Diba? It sounds like systematic, but ito mismo actually yung kung saan familiar tayo or traditionally na ginagamit natin in this compound, in naming this compound. It's the acetic acid, the common, diba? So, semi-systematic siya. Another example, familiar man tanan, diba, sa aspirin. Aspirin. This is considered the nickname or kumbaga more familiar nga name sa acetyl salicylic acid. Acetyl salicylic acid. Ito naman semi-systematic. But kung following the IUPAC rules in naming, aspirin is known as 2-acetoxy benzoic acid. 2-acetoxy benzoic acid. Okay? So that's it for different types of names. So may iba ding mga molecules na dalawa lang yung meron siya, systematic name at saka either may trivial name equivalent siya or may semi-systematic equivalent siya. Meron din naman at meron siyang tatlong types of name. Meron siyang systematic, may trivial name, meron ding semi-systematic. Okay? Sige, let's have this concept naman on the kumbaga the rules, the general rules good in naming organic molecules. Okay? So for the purpose lang of better understanding on the general approach to systematic nomenclature, so we have a sample compound being provided on the slide. And let's try to recall, ano ba yung approach dapat, yung step-by-step na approach in naming organic molecule. So first things first is dapat we have to identify the parent chain. The parent chain should be the longest continuous nga carbon connection. Okay? So by just looking at this given example, we could tell nga 7 ang longest carbon chain. And then you make use of the Greek prefix that dictates number. Diba? Pag sinabing 7, that's hept. Okay. Second step, we identify if may presence ba ng double bond, triple bond. Kung wala naman, then we can make use of the ending sa alkane, yung an. Kasi kapag may double bond, mahimo na siya in. Mahimo siya heptene. Kung triple bond, mahimo siya heptyne. Okay? So, identify kung meron bang double or triple. Kung wala naman, then that's heptane or heptane. That's heptane. Next is we identify what is the highest priority group so that it will help us identify kung ano dapat yung suffix ng organic molecule. So, ang pinaka-highest group na observed in this structure is carboxylic acid. Diba, ang atong na-learn kanina, kapag carboxylic acid, it should end with oic acid. So, from heptane, okay, supposedly that's heptane. Pero ato nang i-expect daan, diba, na nagin siya suffix. Ayan. Nagin siya suffix na, ayan, based sa iyahang functional group. And since the suffix starts with a vowel, hindi naman pwedeng isunod na to ang vowel to vowel. That's grammatically wrong. Hindi pwedeng adjacent yung dalawang vowels. So you have to drop the ending E sa heptane. Then you add, ayan, the suffix that indicates the highest priority group in that molecule. So heptanoic acid, so nanatay parent name. After you name the parent name, the root name of the parent, you have to identify now the substituents. So based sa structure, naatay substituents nga methyl, og naapoy chloro. Hatagi na sila og locants lahat. Dapat sila may locants Naatay 3-methyl, naatay 5-methyl, and naapoy 7-chloro. You can now name the given structure. Okay? In naming, we have to cite first the prefixes, yung mga low priority groups. Yan palagi. They are being cited first. And in citing, kung multiple prefixes of the same type, diba kanina, same type of substituents, methyl, another methyl, these are the same. Okay? We can make use of the multiplier prefix. May mo siya dimethyl. Okay? Asa man ang duha ka methyl? Nasa 3 o nasa 5. So, 3,5 dimethyl. Paano naman kapag different types of substituents? Alphabetization will be applied. You alphabetize it. Kinsay una? Si chloro ba or si methyl? So, letter C ang una, di ba? Chloro comes first, followed by the methyl groups. Kindly take note that the multiplier prefixes di, tri, tetra, they are not considered in alphabetization. That's why as being underlined, ato sa i-erase para inyo maklaro ang underlined portion. Ano naman ito? Ayan. Yan siya. In alphabetization, ang ato ang gibasihan nga letters, letter C versus letter M. Hindi yung letter D ng multiplier prefix na di. They are not considered in alphabetization. Okay, so the final name is 7-chloro-3,5-dimethylheptanoic acid. So that's the, kumbaga, general approach in naming, kumbaga, organic molecule na mayroong higher priority groups. Yung pinakamadali talaga nga panganlan is yung mga lower priority nga groups. Alkane, alkene, alkyne. But of course, in learning, for you to learn, no, naming complex, you have to start, di ba, naming alkane first. Kasi kung ano yung na-learn nyo sa naming alkene, it will follow sa alkene, sa alkyne, sa alcohol, sa mga carbonyl containing a compound. So, nga naman gina siya. So, ang gihatag diri is the complex na agad. Okay? So, going down dayon to its derivatives, paano mag-name ng derivatives ng carboxylic acid, so on and so forth. So, you try to recall them. Pero, again, ayaw kayo ninyo siya i-dwell too much kanang mag-name good mo, mag-focus na mo sa naming. Kay, again, dili kayo siya good gina-question ang naming. It's just have this as your foundation, kumbaga, in understanding concepts sa biochemistry and even sa medicinal organic chemistry. Para kung may nakita kayong compound na ends in amide, then we could tell nga it has an amide functional group. Kung nag-end siya OH, so na siya ester. Okay? Kung mga dungog taog methyl, isopropyl, then we could tell nga these are substituents. Okay? So, ana lang. Just know the basic lang yun. Maura man gina siya sa board exam, the basic concepts. Pero, syempre, sa leseo pa lang, dapat muagi na gid mo og complex. Kasi in that way, kung nasanay na mo sa complex, madali na lang sa inyo yung mga basic. Kaysa naman puro basic ang amo ang way pag-assess sa inyo dili mo ready sa mga complex later on. Okay? So that's why we practice that sa inyo, sa undergrad pa lang, mga complex question na gidaan ang inyuhang i-practice. Para piyungan na lang dahil ninyo, no, ang basic na mga questions. Sige, let's have bonding principles naman at saka hybridizations. Okay, for the first table, this lists the most important na mga elements sa organic compounds. Palagi, naagin na siya carbon, di ba? Carbon, kapag organic molecule. And that's the main focus good nga atom nga aaralin natin in organic chemistry. Aside from that, napod tayo nitrogen, most important element din yan sa organic molecule. Oxygen, mga halogens, and of course, hydrogen. So in this table, this only shows the number of valence electron for each common elements in organic compound, including the number of bonds for them to reach octet state. So kindly take note, this is also a basic concept, no? Ang carbon, naman siya apat na valence electron, always yun na siya. Niya i-share iyahang 4 valence. Never will happen nga na ay lone pairs, lone electron ang carbon. Always yun na siya surrounded by bonding lines. I-share gina niya ang iyahang 4 valence electron, ha? So, it says here nga it forms 4 covalent bonds. Okay? For nitrogen, meron siyang 5 valence electron. And when you check its electronic configuration, you try to write its electronic configuration, you will realize nga lalang siya duha ka p orbital nga unpaired. Not duha, tulo. Tulo ka p orbital nga unpaired. That makes it capable to share its 3 nga unpaired nga p orbital. So it is always surrounded by 3 bonds. So nitrogen na siya 3 bonds, and then to complete its octet state na siya 1 lone pair. Ang carbon always yun na siya mag share, di ba, sa 4 valence electron. That's why pwede na siya surrounded by, sulat na ako sa baba, surrounded by 4 single bonds. Pwede din may isa siyang double bond, or meron siyang isang triple bond. Or pwede din naman dalawang double bond surrounding it. So muna siya. Apat lahat yung covalent bonds surrounding it. Si nitrogen naman tatlo. Then yung isang pair, lone pair. Pag oxygen naman, 6 yung valence electron. Pag isulat niyo yung electronic configuration ng atom oxygen, makita ninyo na ay p orbital, duha kabuok nga p orbital nga unpaired. That is where kailangan to niya i-share. Okay? Forming 2 bonds, and then the remaining to attain octet na siya 2 pairs ng lone electrons. Pairs. Lone pairs. 2 lone pairs of electrons. Kung mayroon kag lone pair, ang number of electrons diha kay pair naman, so duha ka electrons. Okay? Sige. Then for halogens naman, sulat niyo ulit yung electronic configuration niya. Na siya isa ka p orbital nga unpaired. So capable lang siya mag-form og 1 covalent bond. That's why it is always, or most of the time, not really always, kasi naay times nga expand some of the halogens, na ay mga molecules nga if they become central atom, they tend to expand their outermost shell. But most of the times kung simplest organic molecule, tapos merong mga halogen, usually they are surrounding atoms lang talaga. Okay? Surrounding atoms lang sila. They are placed outside the central atom. The same with hydrogen. So, i-label nyo na lang din kasali si halogen. So, as surrounding atoms, then isa lang yung bond na kaya nilang i-form, covalent bond. So, hydrogen, isa lang. So, always gina si hydrogen, very, kumbaga, basic knowledge to everybody. Hydrogen can never be a central atom. Surrounding atom lang gina siya. Walang lone pair, okay, ang hydrogen. Walang lone pair ang hydrogen. Okay, for halogens, kung surrounding atom sila, then to complete its octet state, na siya surrounding 6 lone electrons. 6 lone electrons. Or that's also equivalent to 3 lone pairs. 3 lone pairs. For halogens, ha? Sige. Next. Okay, focusing on carbon. Kasi yun naman talaga yung atom, di ba? Focused sa organic chemistry. We have mentioned nga ang carbon atom it has variety of properties. Na-mention natin, it is said to be stable, di ba? Kasi able siya to share always. Okay, again, ang carbon atom, it is said to be stable. Kasi nga, it is able to always share its 4 valence electron forming 4 covalent bonds. Ayan. So that's why natay carbon nga pwedeng surrounded by puro single bonds or pwede din isa double bond, isa triple bond, or in some other molecule, surrounded siya by 2 double bonds. Okay? However, if we try to go back to the ground state nga electronic configuration ng carbon, ang carbon, di ba, yung electronic configuration having 6 nga atomic number. Tama ba? Okay, 6 yung atomic number ni carbon. Kung atong isulat ang iyang electronic configuration, it's 1s2, 2s2, and then 2p4, di ba? Or sige, para mas klaro yung presentation ng orbitals. Halimbawa, yung orbitals are represented by boxes. Kapag S, isa ramang yun ang orbital kapag S subshell. So, isa ka-orbital sa 1s, isa ka-orbital sa 2s. How about P subshell? Ilan ba yung orbitals ulit gani sa P subshell? Ilan ba? 1, 3, 5, 7. Go. Hello, naapa ba mo diha? Okay, very good. It's 3. Again, kapag P subshell, tulugin na ha ang iyahang orbitals. Karon atong i-distribute ang electrons. So sa 1s na duha, sa 2s na duha, paano ba mag-distribute ng electrons sa more than 1 orbitals nga subshell? Dapat Hund's rule. Nanubra na. Sorry. Okay, nanubra na. Ito sa erase para dili mo ma-confuse. Ayan. Ayan. Okay. Ayan. Sige. So, dili ni siya 4, 2 ra ni. Nanubra na ang electrons. Dapat 6 raman. Tama ba? No? 6 ra, di ba, ang atomic number ni carbon. So, 1s2, 2s2, and 2p2. Okay, 2p2 ra taman. Okay. So, yung dalawang electrons sa 2p, ato i-distribute singly. Okay? So, kung imong lantawon at a ground state, ang electronic configuration ni carbon, duhara ang unpaired nga p orbital. So kung imo siyang i-realize, so meaning to say, duhara yang ma-share na electrons. But how is it possible nga iya man daw kayang ma-share always iyang 4 valence electron? Ang valence electron katong makita sa iyahang outermost shell, ha? Iyang outermost shell is until 2nd level. Okay? Iyang highest energy level is 2. Di ba yan yung n value, the principal quantum number? The n value represents the highest energy level. Nandoon yung mga valence electron. Ang focus lagi nato would be the valence electron. Kasi sila lang naman talaga yung nagpa-participate sa chemical reaction. Okay? So yung 4 na valence reaction, electrons, bakit kaya iyahang ma-share siya despite nga at a ground state, duhara man nga unpaired. No? So, kanira dapat iyang capable ma-share. Okay? So, the reason why ang carbon atom is able to form this kani nga mga properties of bonding, pwede siya mag-form of double bond, triple bond, pwede puro single bonds tanan. It's because of this concept on hybridization. Okay? And by the way, that hybridization nga concept is also a property ng carbon. Marami siyang hybridization types nga kayang ma-form. Okay? And because of that concept, kaya niyang i-share ang 4 niya na valence electron. Ito ground state pa man ito, di ba? ground state electronic configuration. So, kapag excited state ngayon, yung atom ng carbon, one electron from its p orbital, one electron from its 2s will jump to the p orbital. So mula sa yung ground state, tingnan nyo, para magka-unpaired or half-filled lahat ng orbital in a carbon atom, kaya pa may bakante, di ba? Okay? One of that electron from 2s, ito siya, it will jump, okay, to one of the p orbital ng carbon atom. Sorry. Ayan, so ato siyang katulunahan, nag-saving pa siya, ayan. Ito yung nangyari. Diba from 2s, S2 rather. From S2, dalawa dapat yun kanina at ground state. Naging excited state man ngayon, yung atom ng carbon. Ang nangyari, at an excited state, one electron will jump to the p orbital. Ito na yun. Diba? Kanina sa ground state, bakante pa yung dulo ng p orbital. Okay, so one electron jumps to the p orbital, giving now 4 valence orbital. And it is now capable to form one bond each. Capable na siya mag-form ng one bond each, totaling to 4 bonds, of course. Kumpara kanina. Kanina, dalawa lang yung half-filled. So, atong realization, dapat is, duha ra gyud ka bonds ang ma-form ni carbon. For the reason pala, it's because of, at an excited state pala, mabubuo yung 4 na orbitals capable of forming a bond. Now, the problem sa given nga presentation dito above, meron lang siyang isang sigma and 3 pi bonds. By the way, na wala na ako na-discuss, no, ang table na to, ni jump off ta. Sige, mabalik sa ta dire nga table. Ano ba yung nakalagay dito na table? Sigma and pi bonds, these are 2 types of covalent bonds. Covalent bonds lang naman talaga yung ma-observe, di ba, sa organic molecule. Covalent bonds are those bonds that are observed between non-metal to non-metal. At a molecular level class, kana nga bond nga nagko-connecta sa non-metal to another non-metal, ang mga nabubuong bond dyan could either be a sigma bond or a pi bond. Again, these are 2 types of covalent bond. Okay, paano ba nabubuo yung sigma? Ang sigma bond class, that is formed from head-on collision. Head-on collision of an orbital with an S character. Maghatag og example, ha? Example, hydrogen. Diba ang hydrogen na ashay? Let's say, the compound is hydrochloric acid. Siyempre, ang nagko-connecta sa atoms na yan sa hydrochloric acid is covalent bond. Anong klaseng bond ba yan, yung nagko-connecta sa hydrogen at chlorine? Anong klaseng covalent bond? It's actually a sigma bond. Kasi, there's only a collision or head-on collision ng any orbital meron sila na may S character. Ang hydrogen, di ba? Sorry, kaya halihok kaayo ang akong slide yun. Okay? Kaya nagamit ako sa ako ang PDF handouts. Di ba? Ang hydrogen is 1s1. Okay? So, kumbaga, kani nga hydrogen atom, naana siya'y half-filled. One half-filled nga S. Circle akong gidrawing sa S, kay spherical man, diba, ang S subshell. Naalala ba yun? Ang S subshell spherical, ang P subshell dumbbell shape. Yun. Okay? So, na siya'y 1 electron sa yung S. Okay? And that's the only valence electron meron ang hydrogen. Si chlorine, kung imong isulat yung electronic configuration ng chlorine, di na ako isulat diri, ha? Basta, please know nga ang chlorine sa iyahang I believe it's 3p. Diba? Tatlo man yung orbital sa p subshell. Naana siya'y isa ka p, p orbital, okay, sa iyang third shell. Yung last good nga orbital meron ang atom nga chlorine nga unpaired. Okay? And this is a p orbital man. Okay? So dumbbell shape. Ayan, di ba nga na ang dumbbell shape? So mahitabo lang dira is ito yung sa hydrogen. Yung isa dyan na unpaired orbital, meron si chlorine, it will just share its electron. Meron si hydrogen sa kanyang 1s. Head-to-head collision ang nangyari. Head-to-head collision of orbital. Are you following? Yun yung sigma bond. Hello? Madunggan pa ba ko? May I ask if you follow the discussion? Can you show a thumbs up? Okay, please respond. Thank you. O yan. Yan po yung sigma bond na head-to-head collision. Any orbital, basta may S. So kani, you have an S, tapos may P. Basta kung ang nag-head-to-head collision na ay S, na characteristic, sigma bond, yun na siya. Pero, in a case nga puro pi bond, not pi bond, p orbitals rather. In the case nga, ang covalent bond na buo siya because of sideways collision ng p orbital, as in pure p orbitals, walang halong S. Puro p orbitals yung nag-sideways collision, that's a pi bond already. Okay? Ano ba yung example? You can actually search a lot of examples sa Google Chrome. Basta yung concept dito is puro p orbitals. Sige, mag-drawing na lang ako ng p orbital. Halimbawa, you have an atom. Okay. An atom nga X na asyay. Ganito. And an atom nga Y. Okay? And then, they form a double bond with each other. Okay? So, yung double bond dyan, or yung second bond dyan, that's actually a pi bond. Okay? Yung pi bond na yan, nabubuo pala siya kapag merong sideways collision. Diba? This is 1p orbital. Sorry, delay ang sulat, no? Nag-draw na ako ng p orbital. Ayan. And then for Y nga atom, naapod siya p orbital. Sideways yung collision. Puro p orbital. So, dyan yung nag-sharing. Atong i-change to color red. Color red. So, yan. Nasa taas. Ayan. Color red. Ayun. Sige. So, kung sideways naman class, ang collision. And then, puro p orbitals. P orbitals, yung dumbbell shape, di ba? Ang p orbitals. Pi bond yun. Okay? Now, sa mga structures, kailan natin masasabi nga sigma bond yan? Kailan nga sasabi na pi bonds yan? Ang sigma bonds class is always the first bond. It's always the main bond. Yun mismo yung unang bond na nagkokonekta sa isang atom to another atom. So, kung tatanungin ko kayo, ilang sigma bonds ba yung bumubuo dito sa first structure presented on the slide? Surrounding a carbon. Ilang sigma bonds? Go. Kung sabi natin ang concept ng sigma bonds, it's the first bond surrounding a central atom. There are, how many sigma bonds? Go. Okay, 4. How about here? Dito naman, ayan, sa kabila, delay, no? Ayan. Ilan yung sigma bond? Dito naman, 3. Okay, very good. Yung unang bond, yan yung sigma bonds. 3 yung sigma bonds. Nasaan yung pi bond? Yung pi bond class, it's anything bond after sigma. Okay, very good. Itong nasa pangalawang bond after sigma bond, ayan, that's a pi bond. Okay? And then, dito obviously, dalawa ang sigma bond, dalawa din yung pi bond. Akong i-encircle ang pi bond ha, ito yon. Basta always ha, ang main bond, first bond, it's the sigma bond. Then sa multiple nga mga bonds, ang ikaduha or ang ikatulo na, gikan sa first bond, yun naman yung mga remaining pi bonds. So dito din, dalawa ang sigma bonds, dalawa ang pi bonds. Yung una, sigma, ang nisunod nga bonds, pi bonds yun. Between the two, weaker yung pi bonds. Kaya nga when we discuss, I don't know if you can still recall it. I hope no inyo na siyang na-scan while nag-review mo advance sa mga reactions. 'Di ba may nasabi doon nga kapag reaction ng sa mga alkenes, ang first nga mahitabo is breaking of the pi bonds. Bakit ang pi bonds yung magbe-break? Kasi it's the weaker bond compared to the sigma. Sideways collision lang kasi yung nangyari. Okay, so sigma is a stronger bond because there is a head-to-head, terminal-to-terminal collision ng orbital. Okay? And going back to carbon, yun na nga, the reason bakit capable siya nito mag-form ng 4 na sigma bonds or in other molecule, 3 sigma bonds, isa pi bond, or sa ibang molecule, 2 sigma bond or 2 pi bond. It's because of this concept nga, yung hybridization na concept. Kaya kung dito lang tayo mag-base na concept, it doesn't explain at all the property ng carbon nga it is capable of catenation. Diba mayroon kag catenation, it could form multiple bonds within itself. How is it possible nga kung kanilang ang atong basihan nga concept? Kaya kung kanilang, diba, na siya S, orbital nga half-filled. Ibig sabihin yan, it could only form 1 sigma. Then na siya tulo, ka half-filled nga p orbital. Diba? Kung p orbital to p orbital ng other atom, pi bond yung mabubuo. So, tulo ka pi bonds ang iyahang mabuo. So, di ni siya maka-explain nga concept ani. Diri pa lang daan, na ihok kay atong slide. Okay, dito pa lang 4 sigma bonds no yung kaya niyang mabuo, di ba? Kung puro single bond. Ayan, kung puro single bond yung bumubuo sa carbon, central carbon, equivalent na yun sa 4 na sigma bonds. How can that explain, no? How can this concept explain that property ng carbon? Na isa raman ng iyang half-filled S. 1 sigma ra gyud na iyahang buo nga bond. So with the help of this concept, hybridization, kaya na niyang mag-form ng multiple bonds. Pwedeng puro single bonds sa iyahang surrounding or na ay double bond ba kaha or maroong triple bond. So what is hybridization ba? This was introduced by Linus Pauling. And this is all about mixing. Imi-mix lang natin yung 2 or more orbitals to form new set of orbitals. There is simply mixing. Okay, imi-mix lang natin yung available na orbitals meron ang isang atom in its outermost shell para makabuo tayo ng bagong set of orbitals para ma-exhibit ni carbon itong mga properties na to. Okay? Sige. So, yung first na nangyari, di ba, sa ground state, ito pa yon. Sinulat ko na yan kanina. Yung kanina nga ground state electronic configuration of carbon atom. Yan yon. At excited state, kumusta ngayon yung electron na to from 2s, it jumps to the empty nga p orbital, di ba, sa carbon. And yun na nga, hybridization will happen. Pwedeng, syempre, ito lang yung focus natin kasi ito yung mga nasa last shell. Second shell, nandoon yung valence electron for carbon atom. Okay? So, imimix lang yan. Kumbaga, pwedeng ang mixing isang S. Ito yon. Isang S orbital plus, pila man ang ka-p orbital ang i-highlight, tulo daw kabuok. So, is 1, 2, and 3. Gimix lang sila. Delay ang sulat. Ayan. So, kung pag-mix na isa ka S, then tulo ka P orbital, mahimo na siya sp3. Okay? sp3 ang tawag sa bago or sa hybrid orbital. And kapag sinabing sp3, di ba apat yan lahat na orbital ang gimix. 1, 2, 3, 4. So meaning to say, kapag sp3, apat na orbitals yan lahat. Okay, apat man ang orbitals imong gimix. So kung mayroon kag sp3 hybridized si carbon, meron siyang apat na half-filled sp3. Okay? Which is capable of forming 4 sigma bonds. 4 sigma bonds ang kaya niya kasi merong characteristic ng S. Diba kapag ang orbital may characteristic nga S, capable yan mag-form ng sigma bonds. Okay? So ang tawag na ito kung hybrid na siya nga orbital, sp3 na ni. sp3, sp3 each. sp3 na. sp3. Kaya na hybrid naman siya. Na-mix naman sila. Okay? Another type of hybridization na pwedeng mabuo with carbon atom is combining 1s orbital niya at its excited state plus dalawa sa kanyang p orbital. So, isa ka s, duha ka p. Ang pangalan niya, sp2. Muna siya ang gi-highlight. Kanang gi-highlight mismo. Nga color yellow, mura na siyang gi-combine to sp2. Pila man na ka-orbital ang gi-mix? 1, 2, 3. Therefore, kung sp2, pila na ka-orbital? 3 orbitals. Half-filled. sp2 nang tawag dyan. sp2, sp2, sp2. Half-filled nga sp2. Okay? That's why, meron ulit character nga s orbital, kaya niyang magbuo ng 3 sigma bonds. Okay? Pag sinabing sigma bond, it's the first bond, ha? Okay, first bond, the single bond mismo. Okay? Then, tingnan nyo. Di ba may isang p orbital dyan na hindi kasama sa mixing, hindi kasama sa hybridization? Tawag natin dyan is unhybridized. Hindi naman siya kasama sa hybridization. Unhybridized. Tama ba yung spelling? Ayan. Now, yung unhybridized nga p orbital, yan yung bubuo sa pi bond. Kaya, kapag sp2 hybridized ng isang carbon, meron tayong makikitang isang pi bond. Kasi meron siyang isang unhybrid nga p orbital. Pure, ragid siya nga p orbital. Moment to atong definition sa pi bond. Dapat, kung pi bond, pure gid siya nga p orbital alone. Okay, so naaman siya available, unhybrid nga p orbital, isa, so capable yan mag-form ng 1 pi bond. And then lastly, you have mixing lang ng isang S at saka isang P, yan naman yung SP. So duha ka orbital na siya, 2 orbitals yan lahat. Okay? So may characteristic of an S, so dalawang sigma bond yung mabubuo dito. Ay, sorry. Sigma, ito na yung symbol, then bond. And then, dalawa pi bond. Bakit dalawang pi bond? Na may duha ka anhybrid nga p orbital. P orbital. Ito yung sp. Ito yung sp. Okay? So, yan yung different, kumbaga, hybridization capable i-form ng carbon. Ito din yung summary. Ito yung summary. Sinabi natin kanina, yung mga nasulat dyan. Kapag sinabing sp3, isa s, tatlong p, apat, yung orbital, sinabi natin yan ha, kanina. Kaya capable siya mag-form ng 4 sigma bond. Pag sinabing sigma bond, it tells us nga puro single bond yung surrounded. 4 sigma bond around a carbon atom. Ibig sabihin din yan, apat na puro single bonds surrounding a carbon. So if that is the case, apat yan na electron groups, tetrahedral shape yan. Diba? Kung tetrahedral, kung surrounded siya, kung ang central atom surrounded with 4 electron groups, tetrahedral yun. And kapag may shape, na siya equivalent ideal bond angle. Pag tetrahedral, the ideal bond angle is 109.5. Alright? Pag sp2, isa S, dalawa ang P. Ito din yon. Sinabi na natin yan kanina. To reinforce lang. And then, tatlo yan lahat, ang sp2 orbitals. Then, siya isa ka unhybridized na P orbital. Unhybridized na P orbital. Kaya, capable siya mag-form ng 1 pi bond. So, ibig sabihin, kung sp2, ito, sp3 hybridized na siya nga carbon. Kung may tag sp2 hybridized nga carbon na siya, ayan, tatlong sigma bond. And let's say yung kulay blue, yan yung pi bond. Ayan. Okay. Again, yung kulay pula, puro sigma bond yun. Kulay blue, pi bond. So, naka-sp2 hybridized ito. And then finally, kung sp hybridized naman ang isang carbon, central carbon atom, ibig sabihin, meron siyang dalawa lang na sigma bond surrounding it. And then yung the remaining are pi bonds. Okay? Or pwede din naman, meron siyang, ayan, color blue, remaining color blue again ha, are pi bonds. Medyo delay yung sulat. Ayan. So, sp hybridized yan. Kapag, ayan, yung carbon, merong 2 double bonds surrounding it or 1 triple bond surrounding it. Lahat ng color blue na sinulat natin, pi bonds yan. Okay? Lahat ng kulay pula surrounding carbon nga bonds, sigma yun. Okay, there are questions, no? I think sa mga I have encountered before, sa mga review materials, ginapa-identify, ilan ba yung sigma bond sa whole molecule? Ilan ba yung pi bond sa whole molecule? Gaano pa kalaki yung molecule? You just have to count it. Basta yung unang bond talaga palagi, main bond that connects two atoms, counted na siya as sigma. The remaining na dayon are pi bonds. Okay? You can make use of the tables kasi mas easier, di ba, ang familiarization kung in table format yung presentation. So, can you take note of this ha, kapag sp3, atong i-recall. Kung sp3 hybridized ang central carbon, puro single bonds. 4 na single bonds. Kung sp2 hybridized ang carbon, merong isang double bond. It contains 1 double bond. That's it. Okay? And therefore, the shape is in trigonal planar. Kasi that's equivalent to total of 3 electron groups. Counted na siya as 1, 2, 3 electron groups. Kung 3 electron groups surrounding a central atom, trigonal planar yun. Okay, and then kapag naman ang central carbon is in sp, hybridized, pwedeng meron siyang 2 double bonds or meron siyang, bonds. 1 triple bond. Okay, and that's linear shape. Linear shape, bond angle ideal is 180 degrees. Okay, so that's it for the concept on hybridization. Okay, let's move on to intermolecular forces of attraction. Although this is also given emphasis naman sa inyong, probably sa inyong fee farm before, na mga topics on intermolecular forces of attraction. Sige, let's make use of this table. But before that, let's have first, no, ano ba yung kumbaga definition ng intermolecular forces of attraction. The word inter, that stands for between. It means between or among different things. So kumbaga, it is the chemical bonds that is being formed between molecules. Okay? Kaya interaction. Diba? Kung may tag-interaction nga word na akay ka, interact na lain. Okay? Nga lahi, nga, let's say, entity. Okay? Inter. So, between. Iba naman yung intra. Yung intra kasi is just one molecule. Just one molecule and just within that one molecule. Meron ding bond, no? Ma-observe within. Intra yun. Intra, kung within. So, between molecules, the forces of attraction being observed are intermolecular forces of attraction. And these are the intermolecular forces of attraction summarized in the table. Kindly take note. Ang arrangement dito is based on increasing strength of attraction. Kaya tingnan nyo sa column ng strength, pa-increase yung strength ng intermolecular force being formed. So meaning to say, ang van der Waals na force of attraction is the weaker, okay, type of IMF. This is actually abbreviated as IMF. And then the ion dipole is the strongest. Okay? But the one that is commonly observed talaga sa organic molecules, yung first three. Kani being observed na siya sa organic molecules. Yung last na hindi masyadong highlight, common ito sa inorganic. Okay, not na siya for organic molecules. Ito common sa inorganic compounds. Usually, kapag may presence of metals. Diba? Pag inorganic compounds, and then may term na ionic, then there's involvement of metals. Ionic bond, for example. Okay? Now, yung van der Waals or London dispersion nga intermolecular force of attraction, when it comes to its requirement, wala naman masyadong specific nga requirement na or kumbaga significant na identifier for this type of intermolecular force of attraction. Basta, common ito sa mga non-polar molecules. Yan yung palatandaan natin. Basta van der Waals, common sa mga non-polar molecules. Example, mga lipids, oils, waxes. Okay? Carbon-rich, basta carbon-rich nga mga molecules. Lipids, those are, kumbaga, there is an existence gyud ana nga van der Waals or London dispersion type of intermolecular force of attraction. Bawa pinaghalo yung oils at saka waxes. Halo yung mga force of attraction involved there are London dispersion and it's so weaker. Yung palatandaan ko dito is yung, di ba na ay kanta nga, London Bridge is falling down. So bakit siya na fall down? Because it's weak. Okay, yung strength niya is weak. Compare sa kapag may metal. Diba? Opposite attracts. May portion nga positive pole talaga. Okay? Full charge man gini siya. Kung may metal. Positive man gid na ang pole sa usa ka metal, diba? Kapag may dipole, okay, that could either be having a partial charge. Kung dipole, partial charge naman na siya. Pwedeng, let's say, partial negative charge. Okay, so kung i-compare mo siya sa van der Waals, very strong talaga kapag may presence of metal. Opposite attracts. Kapag may full charge of positive and then just a partial negative charge, obviously, strength of attraction is really that strong. Dipole, by the way, the term dipole, may nakasulat dito. Dipole nga term that describes if there is presence of electronegative atom in a molecule. Okay, sabi dyan, once a polar bond exists, the partial charge between bonded atoms are called dipoles. In short, kapag may presence of electronegative atoms, kasi they are the ones talaga that are capable of forming stable negative atoms good. Basta electronegative atoms, presence of, sulat natin, electronegative atoms. Okay? Yun yung, kumbaga, basehan natin. If there is a polar molecule, a polar bond that exists, presence of electronegative atom. Kaya, under dipole-dipole and hydrogen bond, okay, may nakasulat dyan nga partial charges are observed. And even on the next nga mga columns, you will observe presence here of electronegative atom, like carbonyl. Sa dipole-dipole, diba ang carbonyl is carbon, double bond oxygen. So obviously, we'll observe, ma-observe natin dito, partial charges talaga, permanent charges, na kung saan partial negative charge is observed for oxygen, partial positive charge is observed for carbon atom. So yung oxygen dyan is the polar group, presence of electronegative atom. Okay? Almost equivalent yung dipole-dipole at saka hydrogen bond. Only that, very specific talaga yung hydrogen bond. Nabubuo lang siya kapag may hydrogen to oxygen, hydrogen to nitrogen, or hydrogen to fluorine interaction. Kapag may interaction si hydrogen towards highly electronegative atom. Specific nga lang siya, no, sa these interactions ng mga atoms. Okay? But the rest nga presence of electronegative atom na hindi naman siya nakabond directly to hydrogen, then the best classification niya is dipole-dipole interaction. So, halimbawa, mga, let's say, for hydrogen bonds, mga water molecules, pinaghalo mo lahat. Water to water molecule. So, na siya, interaction ng mga water molecules. Maraming water molecules. So, the intermolecular force of attraction observed here is a hydrogen bond. Kaya mataas yung chance na yung hydrogen ng isang molecule pwedeng mag-form ng interaction sa oxygen ng other water molecule. Or vice versa, itong oxygen ng isang water molecule, may attraction siya sa hydrogen ng isa pang water molecule. Yan yung intermolecular forces of attraction. So obviously, hydrogen bond is being observed here. Okay? Halimbawa, sa dipole naman, pwedeng gawin natin example yung mga carbonyl containing ng mga compounds. Halimbawa, acetone. Example, acetone ending in -on, obviously, ang carbonyl compound dito is yung ketone. Diba, ang carbonyl is carbon double bond O. Kapag acetone, it's CH3CO, CH3. So, puro acetone, acetone molecules, acetone molecules. Okay. Yung probable or mataas na chance na intermolecular force of attraction observed dito, carbonyl to carbonyl to carbonyl groups, dipole-dipole na interaction. Okay? Basta may carbonyl groups usually. Alright? Sige. With regards to the application, yung hydrogen bonds, very common ito na na-encounter among proteins. Particularly, marami tayong level of structure ng proteins. May primary, secondary, tertiary, quaternary proteins, di ba? Ang hydrogen bond is being observed sa secondary structure ng proteins. Hydrogen bond, yun yung, kumbaga, palatandaan natin. Kapag may nabuo ng hydrogen bond sa protein structure, na-attain na niya yung secondary structure. Okay? And then, kapag sa DNA application ng hydrogen bonds, dyan makikita, observable siya sa complementary base pairings. Naalala yun sa DNA, RNA. Di ba natin complementary base pairings na kung saan palagi ang pair up. Halimbawa sa DNA, ang pair ni adenine is with thymine. Guanine with cytosine. Ang bond na nagkokonekta, no, sa base pairings, complementary. Okay. Base pairings, ayan, base pairs, adenine to thymine, guanine to cytosine, hydrogen bonds. And yung bilang ng hydrogen bonds, let's recall, dalawa hydrogen bonds between A and T, tatlo hydrogen bonds, okay, between guanine and cytosine. You will recall that sa Biochem nga review. Okay? So for now, just know, ngayon yung application ng hydrogen bonds. O-observe siya, syempre, sa organic molecule. Okay? And again ha, yung nasa dulo nga portion, sa inorganic compounds naman yan siya common.